In this next part, we are going to be looking at parallel and perpendicular lines and their slopes. So the first fact is not going to be a big surprise to you, that the slopes are the same if two lines are parallel, and vice versa. If two lines have the same slope, then they are parallel. Let's get used to a little bit of notation. M1 would be the slope of my first line. M2 is the slope of the second line. So in other words, if M1 is equal to M2. Let me give you two equations as an example here. So if my first equation would look like something like this, y is equal to 2x plus 3, that would be y1. And the second line, y2, is equal to 2x minus 4, then these two lines are in fact parallel. We're going to see in the next section that this is a special form of the equation of a line, but this comes later. Now, perpendicular lines, that is a different story altogether. It is a slight little bit more involved because the slopes also have to be special, but the product of the slopes have to be equal to -1. In other words, M1 multiplied, this is a multiplication cross, not an x, with M2 has to give us -1. Let me give you two equations that would illustrate this. If M1, let's use the same one as before, 2x plus 3, then y2 has to be special. It has to be a -1/2 x, and now the constant doesn't really matter. Let's use the same one, -4. These two lines are also perpendicular. And why is this so? Because 2 multiplied by a -1/2 gives you -1. Let's have a look at some examples where we are using this. We want to show that the line passing through 4,2 and 6,6 is parallel to the line passing through 0, -2 and 1,0. Now, how can we show this? That is very simple. We are just going to calculate the slopes, and if the slopes are the same, well, then these two lines were indeed parallel. So, I'm going to calculate slope 1. I'm going to be using the formula right here that says, as a reminder, y2 minus y1 is going to be divided by x2 minus x1, and this will be then the slope. So, let's have a look. y2 is 6 minus, let's put everything in parentheses, that is always the safest way to do this. 6 minus 2 divided by 6 minus 4. Well, opening up the parentheses, this is 6 minus 2 divided by 6 minus 4. And I get 4 negative, hold on, this is 6 minus 2, that is 6 minus 2 divided by 6 minus 4. All right, that will be 4 divided by 2, and that will give us 2. So the first slope is equal to 2. Now I'm looking at my second slope. Same thing again. y2 minus y1 divided by x2 minus x1. Remember that it doesn't really matter which point is y1 and x1 and which point is y2 and x2. It doesn't matter. All right. As I mentioned, safest way to do this is by placing parentheses and then opening up those parentheses later. So we have 0 minus a -2 divided by 1 minus 0. And that will be 0 plus 2 divided by 1 minus 0. And that will give us 2 over 1, which is also 2. And that means the slopes are equal to each other, so the lines were in fact parallel. And there goes my pen. There we go, parallel. Let's do another example. Similar to the other one, there is a slight little difference. Show that the line passing through -1, 4 and 3, 2 is perpendicular to the line passing through -2, -1 and 2, 7. So, in the same way, I am going to calculate my slope. I'm not going to write on the formula again. I'm just going to do it. Placing parentheses. We have 2 minus 4 divided by 3 minus a -1. And if I open up the parentheses, I will get 2 minus 4 divided by 3. Double negative makes plus. So I have a -2 divided by 4. And that in simplified form is a -1/2. Now right now when I see the -1/2, if the slope m2 is anything else but 2, then these two lines were not perpendicular. So let's have a look. Let's do the same thing. I'm first placing parentheses. Then I plug in my point. 7 minus a -1 divided by 2 minus a -2. Opening up the parentheses, 7, double negative makes plus, 2, same thing, and I get 8 over 4, which is equal to 2. -1/2 multiplied by 2 is in fact -1, and that means they were perpendicular.